Okay, write the partial fraction decomposition. Again, what was the first step? Factor the denominator, okay. How is this going to factor? Okay, notice the greatest common factor is x. If I take that out, then what I'm left with is, okay, but that factors. How does that factor? Trevor? It's x plus 1 squared, right? So that's x times x plus 1 squared. So here's our 5x squared plus 20x plus 6 divided by x times x plus 1 squared. Okay, so first step is factor the denominator. Second step, we need to write our partial fractions. Remember, the partial fractions were when we wrote it like a constant divided by the individual factors. So it was a over x minus 3, b over x plus 2. So if I did the same thing here, what would it look like? A over x plus b over x plus 1. And then here's another part, plus c over x plus 1 squared. When you have a factor which is there more than once, then it's going to lead to more than one partial fraction. So, yes, it has to be squared. It has to be squared, okay? So now, what's the common denominator? The common denominator is this. What's the first term, the first partial fraction missing that the common denominator has? It's missing the x plus 1 squared. Okay, what's the second fraction missing that the common denominator has? X and an x plus 1, right? So we need to multiply this by x and x plus 1. And what's the last one missing that the common denominator has? Just the x, right? It's got the x plus 1 squared. It needs the x. Okay, now they all have the same denominator. So we can make an equation from the numerator, right? 5x squared plus 20x plus 6 equals, now this is going to be a times x squared plus 2x plus 1, right? So that'll be ax squared plus 2ax plus a plus bx squared plus bx plus cx. Do you see that? I multiplied the a times all of those. Then I did the distributive property here, bx squared plus bx, and the cx is by itself. Okay. Now you don't have to do it like get all your squared terms together, but in one way or the other, when you set up your system, you're going to have to say, you know, a plus b equals 5. 2a plus b plus c equals 20. You know, you're making equivalences between the like terms, the squared terms on this side, the squared terms on this side, the linear terms on this side, the linear terms on this side, the constant terms on both sides. So I'll do it this one time. 5x squared plus 20x plus 6 equals a plus b x squared plus 2a plus b plus c times x plus a. Okay, now now we can set up our system of equations, right? Make an equation from the coefficients of x squared. What would it be? No. It's 5. Right, just the coefficients, not the x squared. What's the equation for the x terms? 2a plus b plus c equals 20, and a equals 6, right? A equals 6. There was only one constant term over here. It was the a. So that has to equal to 6. So there's your 3 by 3. And it's kind of like in the row echelon form already because one of them's already solved for a, right? How can I find another variable? Right. Put in the 6 for a here, and b equals, right. If I say 6 plus b equals 5, then b equals -1. Okay, then how can I find the c? Plug a and b into this. 2 times 6 plus -1 plus c equals 20. So that's 12 minus 1, 11 plus c equals 20. C equals 9. So when we did our partial fractions, the a would have been 6, the b would have been -1, and the c would have been 9. Go ahead. It's a long process, huh? Yeah. When it's, the answers really would be like this. A is, what do we say? 6 over x plus -1 over x plus 1 plus 9 over x plus 1 squared. Okay? That's really how you would write the answer. And when you check your answers in the back of the book, that's what you're going to find. Okay? Like that.